I finally decided to put a chuck on my 10-inch phase 2 rotary table. I bought this 6-inch grizzly chuck. It's very cheap, 125 bucks. The manual, I suppose you could call it a manual. I have difficulty calling it that. It's almost understandable. It covers several models. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Covers 10 different models. And nowhere that I can find so far is there an identifying mark on the chuck to tell me which model I have. So I took some measurements and found the closest corresponding model to my measurements, which make it a model 160 with a diameter of well, not a diameter, but a 6-inch. Make it a 6-inch chuck. Not really, but that's as close as we can get. Now my problem is finding the bolt circle hole distance in which to for my mounting bolts for the chuck to this 1/2-inch back plate that I'm going to build. Well, I think it's 5.5 inches. 5.59, I believe. I'll figure it out later. What I'm doing right now is I've got a pre-existing hole in this piece of aluminum I found, 1/2-inch aluminum, that I'm going to use for a back plate. I'm going to drill it out so that I can have at least one clamping, clamp on this rotary table after I center right here. This is going to be the center of the plate. After I center it under the spindle, I will have at least one clamp to use to drill the 3 holes for the chuck mounting operation. So this hole, it's just a manufacturing hole, call it that. It has no bearing on the final product. Hopefully there will be a final product with this. All these things sound good. I've always wanted a chuck on my rotary table, and I know the problem, which is that you don't wind up with much distance under the spindle after you build one of these things. There's 14.5 inches from the top of my mill table to the bottom of the spindle. Now, of course, the table's up, so there's not near that much right now. Well, after I get this built, there will only be 4.5 inches from the spindle to the chuck jaws. So that's not much. It's not going to be near as useful as I wanted. Of course, I knew all this in advance. But I will be able to use it. And since this is a horizontal vertical table, rotary table, I'll be able to use it maybe with more facility in the vertical position if I buy the appropriate tailstock. So that's where I am, and I'll be coming back with more updates. I'm drilling the 3 holes that I'll need to mount this plate to my 3-jaw chuck. They're spaced 120 degrees apart on a 5.59 inch diameter bolt hole circle, 2.975 or 2.795 inch radius circle. I'll also, once these 3 holes are completed, I'll also use them as holes to clamp down this piece of aluminum to the rotary table as I make it round with an end mill. That's always fun. I'm on the last hole of those 3 that I need to bolt this plate to the 3-jaw chuck. I've through drilled them 5/16 and then quote countersunk them unquote ½ inch down to, or counterbored them rather, down to 0.320 inches. I don't have the proper counterbore, so what I did was positioned a ½ inch drill bit right over that 5/16 hole, and then just got it to cut full width, and then inserted a ½ inch end mill, and I'll go down to 0.320 depth, which is this distance here. And I can't put them in correctly because I don't have enough distance from the table, but you can see that'll I think you can see that that'll cover the head of the bolt real easily. So I'm going to go down 0.320, and the way I do that is I know that this rule is, since I don't know whether I've got, I don't know if that's sitting on the surface of this plate, this end mill is sitting on the surface of the plate, or if it's actually down in the depth that I've drilled. But I do know that this rule is 20 thousandths, so what I do is come down there till the end mill touches the rule, set my DRO, and take the rule out, and then go down an additional 20 thousandths and hit the 0 on the DRO again. It works for me real well. Here's what that operation looks like. Not too sophisticated. About 200,000. A little more juice to it. So there wasn't much to that, but that's the way I do it. Maybe I'll one day find the right counter bore. I doubt it. It would be neat to have an entire set. Those socket head cap screws are metric though, and I don't even know what they are. They're the head of the screw is about 0.495 inches in diameter, so I just, or 0.493, I can't remember. I just chose a half inch as a good compromise. Well, the proof's in the pudding. There's that 3-jaw chuck with the sitting upside down on my rotary table. Let's see if these holes I put in this plate are anywhere close. Well, there's one. That one was easy. That one went in. Now, will this one go? Yep. Might have to counterbore them deeper, darn it. 320.320 should have probably been more like, oh, I'm guessing 350. Not a huge issue. So there she is. I will make this plate round. It'll be, this is 6-inch chuck. I'll make the plate about 9 inches in diameter. That'll give me plenty of room here for bolt holes to bolt it to the rotary table. So I'm happy. Earlier, in the previous segment, I had said that I was going to use these 3 holes, which I created to bolt this plate to the back of the chuck. Also use them to clamp the plate to the rotary table in order to mill the plate round. Well, that was pretty dumb. I would have had to create special T-slot nuts for the smaller diameter holes. That's one reason not to do it. The other reason is I need holes out here anyway to clamp with. So I just am in the midst now of drilling. I've decided to use 4 holes to clamp with. I've got 6 slots on my rotary table, and I'm going to use 4 of them to clamp this plate to the rotary table. So I'm in the middle of doing that now. I'll drill a hole. Safety there. Alright, now for the interesting part. I'm going to make this plate round by offsetting it 4.5 inches. It doesn't make any difference in which axis, but I conveniently choose the x-axis for a 9-inch diameter. I'm going to use a 3/8 inch 3 flute end mill. I think it's got TIALN coating on it. I think I've had it a long time, and I believe I bought it from Ultra Tool. It's if I'm correct, it's specifically made from aluminum, but I've never used it, and high-speed steel would work just fine. And in fact, if this doesn't work for some reason, likely because I'm totally wrong about its intended purpose, I'll switch out to a 3/8 inch high-speed steel end mill. I'm going to start off attempting a 50 thousandths inch cut at 289 SFM, which is as fast as my mill will turn at this diameter, the 3/8 inch diameter. So here we go. The chips are likely to fly everywhere. Seems to be going well. I'll stop it for a little examination. Looks good to me. I'll experiment with a little deeper cut, and if I remember, I'll turn the camera back on for something close to the final cut. It seems to like that pretty good. I tried 100,000 and it cut well, but I was having to put more pressure on the rotary table dial than I wanted. I don't believe it was too much, it was just more than I wanted. So I'm going to stay at 75. This is the final cut. It's only 25,000. Should have cleared the chip before I turned the camera on. done. I'm going to go around one more time, but basically that's it. Well, here's the chunks I cut off that what was once a rectangular plate. This is the 3-flute end mill I used. Has absolutely no markings on it. And I used this high-speed steel 1/2-inch 82-degree chamfer tool to toss my little chamfer on the side of the plate that I might come into contact with. Here's the plate mounted to the chuck. And now I will go through the probably difficult task of getting all these bolt holes to line up. Here's a finished adapter plate with the mounted to the chuck and the whole assembly mounted to the rotary table. Turned out like I expected. It was I thought it would be more difficult to get the adapter plate actually bolted to the rotary table. But it went on there like it was machined to do it. However, my holes for the clamping bolts to the rotary table, I might turn those into slots. And as expected, I have this distance, which I had calculated at 5.5 inches roughly. It's turned out to be 5 5/8 inches. That's not a lot. For example, my Albrecht keyless chuck won't go in unless I'll take the jaws out, or of course move the table off to the side. Once it's in, I have a maximum of 2 3/8 inches to the bottom of the chuck with I built this for one project, for I need to make heads for a steam engine I'm working on, and it's going to work for that. Need to drill holes in a piece of aluminum and a bolt hole circle, so it'll work for that. But it may not work for other purposes. However, I've got a couple of these babies. These are 4-inch chucks. This one's a tilting chuck, 0 to 90 degrees, and the other is just a regular horizontal rotary table. I said chuck. This is a tilting rotary table, 0 to 90 degrees. I may dedicate one of those to a 3-inch chuck if I need more room. That would give me a lot more room, because I'll put it back down here. You see, it's not nearly as tall as this phase, 10-inch phase 2. And a lot of the work I do is really small. On the other hand, this horizontal vertical rotary table, if I add a tailstock to it, then it becomes a whole new creature for me. Even without a tailstock, I'll be able to do quite a bit of work with this 6-inch chuck that I've been struggling to do otherwise. So I'm happy with the result. Tell me what you think. Here's an addendum. The chuck opening is about 1 9/16, I believe. And I don't have any opening in this adapter plate. So what I could do is bore me a hole in the adapter plate to at least 1 9/16, and then turn a piece of steel that would fit down into my rotary table and on one end, and precisely fit the hole in the adapter table on the other end. The problem is the rotary table has an MT2 or 3 taper to it, and that wouldn't bother me a bit. So if I turn that piece of steel, that plug, maybe inch long, with that will fit the top ring of the rotary table, and whatever hole I bore in the adapter plate, that would aid me greatly in centering the chuck to the rotary table once the rotary table is aligned with the spindle. So probably a very soon future project. Well, I've indicated this thing in. I align the rotor table with the spindle first, within 5/10 thousandths at least, and then I put my coax indicator back in after I mounted the chuck on the table and bumped it into place with a soft mallet, and I'm indicating with the only I don't know what you call it, stem I've got that'll reach down in there to something like the right place. I'm about ½ inch above the base of the chuck. Okay, that's what I'm getting. About that's a 5/10 thousandths indicator, and I'm getting, I don't know, at the most 2/10 thousandths maybe. Whoops. There. So, I'm happy with this.